exponential decay and exponential growth is very similar. Exponential growth, here's a little side note, exponential growth, when the pattern was you would multiply by 2 or multiply whatever number each time. So it would get bigger and bigger.
This gets smaller.
Perfect. So this one, the decay, is getting smaller and smaller. Which means what's going to be, usually it's a times bx. In exponential k functions, b is going to be less than 1.
Mr. Tobel?
Yeah.
Kobe Brand said like he emailed you about why he's not going to be in class, and he just wanted me to tell you that like he gave you a reason.
All right. Okay, that's fine. And guys, if you need me to post a recording, and I'll say this for everyone, if you need me to post a recording of the lesson, just remind me so I'll post it.
Yeah, I wanted you to record a class and post it for her.
Okay, today's class, sure. So. Yeah. Because I have to upload to YouTube everything, and if I don't get reminded.
Yeah, same, because I have to go in like 5 minutes because I have something to do. So I'm going to need like the recording also.
Okay. So fine. So 1 and 2, we're going to get the table, graph the function, and then we have the function, graph the table. So this one, b is less than 1 in the decay. And if you want to point out, b is greater than 1 in a growth. So the only slight difference is that you're typically dealing with fractions / decimals in your exponential decay. That's really the only difference. So it's only slightly harder. But we kind of already had to deal with fractions / exponents when we had the negative exponents. So we're going to do a very basic one. We're going to do basically 2 basic ones. Like I'm going to do 2 basic ones, or two of them at least. Then I'll give you 1 to do. And then we'll swap to the other side where I give you the table and then we find the exponent or the function. So our first one, let's do a very simple one. Y equals 1/2 to the x power. Very straightforward, very simple. 1/2 to the x power. Remember, if I especially don't point out the domain, make the domain -2 to 2. So y equals 1/2 x power. So very similar to the situation from growth, we're just going to plug in our exponents one at a time and to graph it. Later, we're going to see if we can use the pattern to help us graph it. So first, we're going to plug in -2 power into this equation. So I'll do that in red. 1/2 to the -2 power. Remember, any negative exponents flips the fraction / move things up and down. So I'm going to rewrite this to make this exponent positive. I'm going to flip the fraction 2/1. So any negative exponent will flip the fraction, especially if it's the whole fraction getting negative exponented. Well, 2/1 is simply 2. And then 2 squared is simply 4. So your first value is 4.
Why do you have to flip over the 1/2?
Because of the negative exponent here.
But shouldn't you just bring it under?
But it's 2 is already under. So where is it forced to go?
So wouldn't you make it 1/2? 1/2 and another 1/2. Then you get 2/4. Then you get.
So you're like something like this?
No. I thought you said if you have a negative exponent, you put it under and then you put a 1 on top.
That's true. But this is already under, Shank. So because it's already under, you bring it up because it's already on the bottom. So the only place it has to go is up.
Mr. Tobel,
yeah.
For this one, would you be going down instead of like when you you know how last time you can like times it by that number to get the next number.
Mhm.
Would here you would divide it by the number maybe?
We're gonna
Or-
phrase it as multiplying by a fraction, which is the same as dividing a number. So you'll see, let me plug in the numbers first. Let me do that first, and then we'll do the little shortcut / pattern, okay? And then we could point it out at the end, which is what you're trying to say. So the next one, I'm going to do -1 power. 1/2 to the -1 power. Negative power means I'm going to have to flip that fraction. Anything on the bottom goes on top. Anything on the top goes on the bottom. 2/1 to the 1 power. 2/1 to the 1 power is just 2. So I'm going to plug in a 2 here. Next one, 1/2 to the 0 power. Luckily for us, anything to the 0 power is 1. So that's 1. Fraction or not is going to be 1.
Wait, so would your like pattern be like divided by 2?
Good, and we'll talk about that after this, okay? Then 1/2 to the 1 power. Well, anything to the 1 power is itself, so 1/2. And 1/2 to the 2 power. Everybody gets the 2 power equals. So that becomes 1 squared over 2 squared. Which can simplify to 1/4. That's 1/4. And thankfully, you guys are using the knowledge from yesterday to see that we have a pattern going on. And the pattern, now, the pattern is divided by 2. But I want to make it clear, because we want to frame it so we could do exactly the same thing in growth and decay, is you have to think about it not just as dividing by 2, what are you technically multiplying by? So the pattern you want to express, it's not divided by 2, it's being multiplied by 1/2. And that's the slight difficulty of it. You have to think about it as the pattern is being multiplied by 1/2. Now, when you divide
How
something
come
by
you would do multiply, not like divide?
the reason is, let me show you another example where it's better to say multiply versus divide on purpose, okay? So I'm going to give you one on purpose, and then we'll see how that works, okay?
Do we graph this?
And then you could graph this, yes, and I would ask you to graph something like this. The table would look, or I want a straight lines. The thing would look like this.
So the pattern is like times 1/2.
Times 1/2, yeah. That's how you want to describe this pattern. Goes up to 4, seems like. Don't really need the bottom, but. So, move this away, pattern. Your first coordinate point, which I did in red, is -2, 4, so 2 back, 4 up. Next one is -2, 1. Next one is 0, 1. 1, 1/2, so halfway between 1 and 0, and 1, 1/4. Again, you could change these to decimals if you find it easier for that reason.
Mr.
Makes-
Tubble, I'm just confused how you found like the pattern of times 1/2.
Okay, how did I find the pattern of 1/2? All right, would you agree that it was divided by 2? Like, would you see that it's divided by 2?
Yeah.
Okay, so, and I'll show you how to find this if you see it as a division. If you see it as divided by 2, so whatever your number, which is your y, divided by 2 gets you your new number. Does anyone remember, how do you divide a fraction? What would you do? It's something,
Flip it.
k, go ahead.
Flip it.
Flip it. So you would do a keep, change, flip, which you keep it a y, you would multiply, and you would flip this fraction. Now, you guys were able to see it's divided by 2, which is the same as 2 over 1. So I would flip the fraction 1 over 2. So here, I can see the pattern is y times 1/2. So that's why the pattern is y times 1/2. Now, you also know that because it's literally the value of b in the question.
So if it's always like y equals like 1/2 whatever, then is it always going to be that the pattern?
The one inside the parentheses slash what's getting to the x power, it always will be that one. I'll show you one where there's two numbers, and I'll show you the difference. And then I just want to talk about the decay function. Look at it, it's kind of like flattening it out. If you remember from yesterday, the growth looks like it's going up to the sky. Here, it's flattening out to the ground. So you're decaying to like a low state, while growth, you're growing to infinity. So you want to kind of think of it like that to get yourself an idea of how it should look like. And I don't mind taking any more questions. So if you have it, I'm just going to start writing the next problem we'll do.
This is just a quick question that you might have said already, and I just might have missed it. If we were to write on the test that the pattern was dividing by 2, would that be like wrong?
I would not take points off, but I'm trying to teach you to think of it as multiplying by 1/2. But I would not take points off if you said
Okay.
Okay.
All right, thank you.
No problem. So let's do another one. 3 over 4 times 2 over 3 to the x power. So y equals 3 over 4 times 2 over 3 to the x power. And in this example, I hope you can see why I'm trying to teach you to think of it as multiplying the fraction versus dividing a number. So I'm hoping this example shows that in a clear way. 0.
How come you always use -2 and 2?
Those are going to be the numbers that's the easiest to work with that are whole numbers, because you want like a couple of points. So I want at least 5. Now, what would happen if I put like 0, 1, 2, 3 to the 4th power? The problem with the 4th power is that can make a number so huge that's like hard to understand. So it turns out it's better to do -2 to 2 versus like 0 to 4, let's say. And that just comes from experience / knowing how to teach this the best way. Okay. So what this one I'm going to do is I'm going to use the pattern to my benefit. But before I could do the pattern, I need at least the first step. So I'm going to find what this one is right here. So I'm going to do a little bit math. 3 over 4 times 2 over 3 to the -2 power. There's a lot of things going on in this situation. The first thing is I have a negative exponent here. Because I have the negative exponent here, I'm going to flip that fraction. So 3 over 4 times 3 over 2 to the 2nd power. Because this is the 2nd power, I have to make sure everyone gets a piece of it. So I get 3 over 4 times 3 squared. Actually, I'll just do the math. 3 squared, which is 9, over 2 squared, which is 4. Multiply straight through. 9 times 3 is 27. 4 times 4 is 16. In terms of graphing, it might be easier to change this into a mixed number. In terms of filling in the table, I would keep it the improper fraction. So I'm going to fill it in the table as 27 over 16. But you are not wrong, or there's nothing wrong with taking a calculator and finding the decimal of it. There's nothing wrong with that, okay? So what you have here is 27 over 16 being your first value. Does anyone have any questions on the work for this one? Because I'm going to go on to using the pattern next. Okay. So as I talked about, this number that's inside the x, or being to the exponented, that's not the verb, but whatever, is the exponented, it's going to be 2 over 3. That means my pattern is multiplying each step by 2 over 3. So what I'm going to do here is, instead of plugging -1 and doing all the math, what I'm going to do is, in this situation, 27 over 16 times 2 over 3. And I want to be clear, if you want to do it like we did in the first question, where you plug in each power one at a time, you are perfectly correct and it's perfectly okay to do that. I'm trying to show a different way that some might find easier, while some might find harder, just so you have a couple more options. You can absolutely do it the old way, where you go one piece at a time. I plug in -1, I plug in 0, I plug in 1, I plug in 2. Now, I'm going to continue with this patterned one, even though at some points it's easier just to do the plug-in one, just to show the whole method. So here we got 27 over 16 times 2 over 3. I would like to multiply straight through, but I should try to simplify first from top and bottom. I see a 27 here and a 3 here, so I'm going to simplify the top and bottom. This is going to be a 9 and a 1. I took out a 3 out of both of them. And I see a 16 here and a 2 here, so I'm going to simplify that. This I took out a 2. Here I took out a 2 is 8, which means I'm left with 9 over 8. Which means my answer for here is 9 over 8. Next step, I'm going to multiply again 9 over 8 by 2 over 3. You multiply straight through, but hey, I can simplify again. Cross this out, cross this out. This is 1 and this is 3. Cross this out, cross this out. This is 1 and this is 4. That gives me 3 over 4. Do it again, times 2 over 3. So 3 over 4 times 2 over 3. I can simplify the 1's off. I can simplify this off. So I'm left with 1 over 2. One over 2 times 2 over 3. Could cross out these 2's. I'm left with 1 over 3. Now, if you did it the way where you plug in the numbers and each time, you should still get the same numbers. In terms of graphing, it would look something like this. 27 over 16 is a little less than 2. 9 over 8 is a little bit bigger than 1. 3/4 is a little smaller
I
than 1.
put it as a decimal. Is that fine? Like I switched.
Perfectly
to
fine to
fraction.
put, that's perfectly fine to put it in decimal. Okay? Yeah, that's perfectly fine to do the decimal here. So it's a little bit flatter, but it's still the same situation where it's getting to a flat line at the bottom. Okay. Now I heard it was kind of like radio silence. So I'm sure somebody here has a question. If you have it, please ask it. If you don't want to say it out loud, you could just private chat me. I won't call you out for it, but I'll just answer your question. If you
Mr.
want,
Total.
yes.
For like on the test, am I able to just put it into decimal, or does it need to be into a fraction?
The way I just did it, it would be more easy with a fraction. But since you have a calculator on you, yeah, you could turn it to decimal and then keep multiplying by 2 over 3, or use the calculator to find each piece. That's fine.
Okay.
As I take questions, here's the one I would like you guys to try yourself. I'll make it a little bit more straightforward. 3 times the power of 1 over 2 x. All right, that's fine. She can always check out the review, the recording later. So everyone should be trying this one out. I'm leaving this up here in case anyone's still copying. I kind of did it fast at the end, so I don't want anyone to be left behind. If you have any questions, you can privately chat me about it or ask me out loud. I don't mind. Actually, I'll just pause it and then I'll start doing.
Where's
Hello?
the next problem? Where's the next
In the
problem?
green box one. Y equals 3 times 1/2 to the x power. If you want me to check your work, just send me what your y values are, either as decimal or as fraction, if you want me to check your work. Somebody got me. Rachel, I'm going to assume on the fourth one you meant a 2 on the denominator. So I'm going to assume that's what you meant, and if that's so, then you're correct for all of them. Because
Yeah, that's what I wrote.
yeah, I figured. So yeah, you're good. Good job. Good job. Give a little bit more time for everyone else to try it. Then after this, I'm going to do one problem of finding the pattern. Or maybe, you know what? Actually, I'll say that for Monday. Rachel, this will be your exit ticket, guys. Rachel, you're free to go. So have a wonderful
Thank
day.
you. Have a good day.
You too. Sherelle, you give in decimal. The last number, Sherelle, check your last Y value and then resubmit it. Because the last Y value made a slight mistake. So figure out what you might have done wrong.
In like another like minute or two when everyone's has more time to work on it, can you go over how to do like the first part of it? Because I'm
Yeah.
confused. And I
Like
think
to
I'll get
start
back
it
to the
off?
first part. Yeah, just to start it off. Just the -2.
Sure. Actually, I could do that now.
Look at my answers real quick.
Yeah, give me a second. Sheva. No, something's up. Remember, negative exponents don't make it negative. It flips the fraction. And I think that's why you're getting those negative numbers. Brielle, you're good. You're free to go.
No, the negative numbers is the X.
Yeah, but the X is in the exponent. So it's -2 in the exponent. So that's going to flip it.
No, like, no, I made it like the first number is like the X and the second number is the Y.
Oh, okay. So just use commas in that situation then. Don't do a fraction.
Oh, because I used commas in between the problems. That's why.
I fear you. Okay. So now I understand. You're free to go. Shut it. That's fine.
I wrote
Brielle,
it
you're
wrong.
good.
Okay.
Sherelle, now you got it good. Yarnin, your last one and your second to last one is off. Try to figure out what it is. So your X equals 1 and your X equal 2 is off. Craig, I assume you meant 3/2 for that fourth one. And if that's so, you're free to go. Shank.
Yeah,
You sent
I
me the
did.
answer,
Thank you.
but
Have a nice weekend.
Shank, how are you going to both send me the answer and then ask me what question we're doing? Well, how do you get the answer then?
I don't know. I just did that question with the Y equals 3 and then the 1/2 with the
Well, that
X.
lucky for you, that is the question we're doing. The only mistake is at X
I
equals
know,
1.
it's 3/2. Is it
Okay.
3/2, not 2/2?
Yes, there you go.
Okay.
Galit, you're
Thank
free
you.
to. Good. Galit, you're also free to go.
Can I leave?
Yeah,
Thank you.
no problem. So I
Mr.
want to talk about the first one to start off. So that
Sorry, Mr. Tobo, sorry, I was in the bathroom, so I didn't. What question is it again?
this question right here.
You just check if I got the last two right now.
Yes, you got it now, right? Good, Yarn.
I see what I did. I multiply instead of just like doing it to the power of.
That's what I guess. So yeah. All right.
All right. Thank you. Can I leave?
Yes.
Have a good weekend.
You too, man. All right. So, Huppert, you asked how to start this off with like the -2 part. So we're going to do 3 times 1/2 to the -2 power, right? Now, Huppert, you're going to answer me. What do you do when you have a negative exponent?
You flip it, but I thought that you also put like the 3, like I thought you put it into the fraction, like you put
Very
7/2, and then
okay. Good question. Because this is the one. Why is this a line? Because this one is the equation. Let me go here. Because this one here has the exponent, only this one is flipped. You do not bring the 3 in yet. You got to flip it and take care of the exponent first.
oh, okay.
So what does it become when you flip 1/2?
2/1.
Good. And I'm just going to write that as 2. All right.
Okay.
Now,
Yeah, then it becomes 4.
Excellent. So 3 times 4 is
12.
12. All right. Continue on with it. All right. Guys on Zoom, if you could send me your answers so I could give you the, it's for attendance. Danielle, I don't know if you've been in a Zoom class before, my bad on my class, but we have an exit ticket. And then if you get the exit ticket right, you get to leave early. So if you could send me the answers for, I'll hide the answers for a second, for this equation, y equals 3 1/2 x, then you could leave early. So that's why I say like you got it right and you get to go. I just want to make sure I don't know.
Okay, thank you.
No problem.
Yeah, so I didn't get them in earlier because I was in the bathroom. I wasn't
All right.
watching.
Oh, okay. Figure. You mentioned that. That's fine. I just wanted to make sure
Yeah.
you guys are okay.
So I have to just like write an answer.
Yeah,
And then
right
I'll,
answer.
and then for
Jacob, you
y
already know
equals
that.
3. Yeah, I know for y equals 3, that one. Because aren't the answers already there?
Oh yeah, I showed the answers already there. Let me hide them. There you go.
Okay.
Because it's important to try it out, and it's supposed to show me like, hey, you understood the lesson.
Yeah, it's also good for the test. It's a little bit
Mhm.
of a review.
Yeah. I'm gonna stop recording because